Dear students, now we solve question number 11 from the question series of IIT JAM 2024 mathematics question paper. This question is in section A, so here only one option is true. This question is based on group theory from abstract algebra, and the question is, which of the following groups has elements of order 1, 2, 3, 4, 5 but does not have an element of order greater than or equal to 6? Here 4 options are given. Option A, the alternating group A6. Option B, the alternating group A5. Option C, S6, and option D, S5. So let us try to find out the group which contains an element of order 1, 2, 3, 4, 5 but does not have an element of order greater than or equal to 6. Here we know that the group Sn is the group of permutations, of n symbols. So S6 is the group of permutation of 6 symbols. S5 is the group of permutation of 5 symbols, and the alternating group A6 is the group of even permutations of 6 symbols. That means S6 contains half even permutation and half odd permutations. That is, order of Sn is equal to n factorial, and the group An is the group of even permutations. Of n symbols. So order of An is equal to half n factorial. That is, Sn contains n factorial elements. N by 2 factorial, n factorial by 2 is even permutation, and n factorial by 2 is odd permutation. So even permutations form a group, and this group is An, the alternating group of n symbols, or the group of even permutations of n symbols. So here in S6, let alpha is equal to 1, 2, 3, 4, 5, 6 belongs to S6, because S6 is the group of permutations of 6 symbols. So alpha is a permutation of 6 symbols, so alpha belongs to S6, and order of alpha is equal to the length of the permutations. Since the length of the permutation alpha is 6, so order of alpha is equal to 6. So S6 contains an element, this element of order 6. So option C is false, because in the question it is said that which group has element of order 1, 2, 3, 4, 5 but does not have an element of order greater than or equal to 6. But S6 contains element of order 6, so option C is false. In option D, S5 is the group of permutation of 5 symbols. So let beta is equal to 1, 2, 3, 4, 5. So it is also a permutation of 5 symbols, but beta is the product of 2 cycles. It is one cycle, it is also one cycle. So beta is the product of 2 cycles of length 2 and length 3, belongs to S5, and order of beta is equal to LCM of 2, 3 is equal to 6, because we know that the order of a permutation, is the LCM of its disjoint cycles. So here beta is the product of 2 cycles and disjoint also of length 2 and 3. So order of beta is equal to LCM of 2 and 3 is equal to 6. So S5 also contains an element of order 6. So option D is also false. In option A, A6 is the group of even permutations of 6 symbols, and order of A6 is equal to half 6 factorial, means 2 into 3 into 4 into 5 into 6 by 2 is equal to 360. The elements in A6 are of the form 1, 2, 3, 4, 5, because 1, 2, 3, 4, 5, 6, it is not an even permutation, because it is the product of odd number of transitions. Transitions means cycle of length 2. So it is the product of 1, 6, it is the product of 1, 5, 1, 4, 1, 3 and 1, 2. So 1, 2, 3, 4, 5. So this permutation is the product of 5 transitions. Since 5 is odd, so this permutation is odd. So it does not belongs to A6, because A6 contains only even permutations, and this permutation is odd, so this does not belongs to A6. But here 1, 2, 3, 4, 5, it is the product of transitions 1, 5, 1, 4, 1, 3 and 1, 2. So this is the permutation. It is product of 4 transitions. Since 4 is even, so this is even permutation and it belongs to A6. And the elements of order 5, because this element, order of this element is 5. So order of this element is 5 and it belongs to A6. Also 1, 2, 3, 4, 5, 6, because this permutation is product of 1, 4, 1, 3, 1, 2, 3 transitions and it is one transition. So it is this permutation is the product of 4 transitions, 1 transition and 1, 3 1 4 1 3 and 1 2. So it is the product of 4 transitions, so it is even permutation, so it is also belongs to A6. And the elements of this permutation is the LCM of 4 and 2 and is 4. So in A6 contains element of order 5, order 4, and 1 2 3 4 5 6. So this permutation is the product of two transitions 1 3 and 1 2, and this permutation is the product of two transitions 4 6 and 4 5. So it is product of two transition, it is product of two transition. So this permutation is the product of 4 transitions, so it is also belongs to A6. And the order of this permutation is, it is length 3 and it is also length 3, so LCM of 3 and 3 is 3. So A6 contains element of order 3. Also 1 2 3 4 5 6, that is 1 2 3 permutation, and this permutation is the product of two transitions 1 3 and 1 2, so it is even permutation and it belongs to A6. So it is also of order 3, and 1 2 3 4 5 6, it is also on transition, it is also on transition. So this permutation is product of two transition, so it is also even permutation, and it contains, and order of this permutation is 2, because this transition means this cycle of length 2 and this cycle of length 2, so order of this permutation is 2. And also A6, since A6 is a group, so it must contain identity element, and identity element is even permutation, so identity element belongs to A6. So order of identity permutation or order of identity element in a group is 1, so A6 contains an element of order 1 also. Therefore we see that in A6, and A6 contains an element order 1, order 2, order 2, order 3, order 4 and order 5, but does not contain an element of order 6. Therefore the option A is true. Since it is this problem is in section A, so only one option is true, therefore option A is true. But in option B, this group, the alternating group A5, that is the even permutation of 5 symbols, and we can check this element, this group A5 contains, this group also does not contain an element of order 6, but this group does not an element of order 4, because in A5 1 2 3 4 5, it is the product of 3 transitions 1 4 1 3 and 1 2. It is the product of 3 transitions 1 4 1 3 and 1 2, so it is not even permutation, but the permutation of order 4, but this element does not contain in A5. So A5 contains does not contain an element A5 does not contain an element 6 of order 6, but A5 also does not contain an element of order 4. But in the problem it is said that the group has element of order 1, 2, 3, 4, 5 but does not contain an element greater than or equal to 6. A6 contain an element of order 1, 2, 3, 4, 5 but A6 does not contain an element of order 6. But A5 does not contain an element of order 6 as well as A5 does not contain an element of order 4. So option B is false. Therefore only option A is true. Thank you.